This is the second module in the Map and Compass series. In this module, you will cover the components of a map as well as where to get maps. For this class, you will need the map file from the file library of the CSM El Toro webpage. Every map tells a story that will contain the 5 Ds: description, details, directions, distances, and designations. Knowing how to identify and use these components is the key to reading a map. So let's look at them in greater detail. Description of the map refers to the name of the map, its location, and important dates. In the upper right-hand corner of the map, you will find the name of the map as well as the location of the area. This particular map is called the Fawnskin Quadrangle, located in San Bernardino, California. The date of the map is located diagonally opposite of the map name in the lower left-hand corner. The dates are important so that you will know when the map was created and updated. For this map, the roads were updated in 2014, with roads in the National Forest updated in 2015. Any road created after this would not be shown. Details of the map are the colors and symbols used, as well as the elevation of the terrain. The colors placed on a map are important in that they help to distinguish the various objects. Brown is used to indicate the contour lines. Brown is used to indicate the elevation of land known as contour lines. The lines connect land points with the same elevation. Learning how to interpret the lines, meaning transforming the flat two-dimensional picture presented on the map into a real-life three-dimensional representation, will come with time as your map skills improve. Once you are able to interpret it, you will be able to identify canyons, mountaintops, side of a hill, etc. Of particular note, brown is also used to mark the triangulation station or BMX marker on a map. This is a marker that is on the map that indicates the place that was used by the surveyors that worked the area to create the map. With this in mind, let's try a little exercise. On the left are some contour shapes as you would be looking down on a map from above. On the right are representation of what it would look like from eye level. Pause the video, match the columns, and then continue. Okay, here are your answers. How did you do? If you missed some, go back and try again. All right, let's move on. Green denotes vegetation. The various types of vegetation that can be found is depicted in a broad manner. For example, when it shows a wooded area, it will not describe the types of trees or density of the forest, or for orchards, it will not tell what is growing there. Blue is for water. Lakes, streams, ponds, or marshes are indicated with this color. The color black indicates a man-made structure. The types of man-made objects will be described like a school or cemetery to clarify what kind of object it is, while others will be generic in the form of a square or rectangle or other type of a shape. Red is used to indicate roads. As you can see from this slide, there are different line structures to denote what type of road is shown. One additional thing about roads is that regardless of the type of road surface they are, when you are talking about a section of the road, describe it as having a curve or bend, a T-intersection, a fork in the road, or a crossroad. The acronym used for this is called STIX. In the lower right-hand corner of the map, the various symbols used on it are shown here, especially the types of roads indicated on it. Okay, let's do another exercise in matching map features. You will need to pause the presentation by using the stop button on the slide bar at the bottom of the screen. There are 17 features presented here. Answer each one of them from one of the 5 descriptors that we have just identified. When you are ready to continue, press the continuation button. Okay, now that you have completed the matching, here are the answers. Stop the presentation and check your answers. When you are ready to continue, press the continuation button. We talked about elevation or contour lines before as brown lines on the map. At the bottom center of the map, the interval for the contour lines is indicated. They are different for each map. The interval posted tells you how many feet of elevation each line represents. It could be 10, 20, 40, or more feet. Every fifth line is marked in a darker brown color and will have the actual elevation written on it. So if a dark line is marked 6,800 feet and the interval is 40 feet, the next 4 lines will be lighter and indicate 40 feet of elevation for each line. The fifth line will be darker and indicate 7,000 feet if ascending, or 6,600 feet if descending. When the lines are close together, it shows the land is steep. If they are far apart, the land is flat. Mountain or hilltops are shown by no longer having the fifth dark contour line. Okay, time for another exercise. Let's get some practice with these contour lines. Stop the presentation and complete the exercise. When you are finished, press the continuation button. Okay, how'd you do? Press the pause button to stop the presentation and check your answers. When you're ready to continue, press the continuation button. Another one of the 5 Ds is direction, or which way is north, and how much is the compass deviation from true north, or what is called magnetic north. North and magnetic north are located at the bottom center of the map. It is a common mistake to believe that the compass needle points to the North Pole or true north. While it does point northward, it is not indicating the pole. Let's see why this is. As you can see from this picture, the Earth's magnetic pole is about 325 miles away from the actual North Pole. Because of this, the compass degree of offset varies from place to place. Case in point, Ottawa, Canada has a 14-degree offset to the west, while Vancouver, Canada is 23 degrees to the east. In the continental United States, the variation is from 20 degrees west to 20 degrees east. In the state of California, it varies from 12 degrees east along the Arizona-Mexico border to 17 degrees along the Oregon border. As you can see, if you followed your compass and needed to go somewhere north of your current location or in any other direction, this offset will have you going in the wrong way. So just what do you do to keep on the path you want to head towards? Keep this question in mind as it will be answered in the orienting map and compass section of a later module. As for now, understand that there is a difference, and that is the important thing to know. As for now, let's look at whether or not you should orient the map using magnetic north, as some people say to do. First of all, to use magnetic north, you would have to redraw the north-south lines for the entire map. Why would you want to when you already have them drawn on the map? Next, you would have to reset your compass if you have a declination indicator on it, or if it doesn't, you have to remember the degree of offset and compute this into the compass reading you are taking each and every time. Finally, if you are communicating with someone, you will have to inform them either beforehand or during the actual transmission that your readings include the magnetic offset. If this sounds complicated and unnecessary, you are correct. In fact, it's not even needed. There is a much simpler way to do this, and we'll cover this in another module. Just be aware that there are people who swear that you must set everything to magnetic north. Okay, now let's look at the fourth of the 5 Ds, which is distance. Maps come in different sizes with respect to the amount of territory they cover. This is noted in the map scale section located at the lower center near the contour line indicator. Usually there are several scales for kilometers, meters, miles, and feet. A map scale of 1 to 25,000 covers a broad territory about the size of Orange County. It gives a great overview, but it will lack details since they will be too small to notice. A map of 1 to 62,500 covers about a 10 by 20 mile range. It has more details than the previous map scale and is good if you need to traverse a long distance, but again will lack fine details since they are too small to see. A 1 to 24 or 25,000 map is ideal for covering the area you want to be in with sufficient detail. Other map sizes are available depending upon who is creating them and whether they are military or civilian maps. Just keep in mind, the smaller the number, the greater the detail. While we are on map scales, let's look at how you can determine a distance between 2 points on a map. If you notice on each scale there is a 0 with gray and white bars with numbers going to the right and a number corresponding with the change from gray to white or white to gray. This indicates the distance for that scale. For example, the number 1 to the right of the 0 on the kilometer scale indicates 1 kilometer, while the number 2 shows 2 kilometers. The number on the feet scale indicate thousands of feet. The number to the left of the 0 indicate fractions of the distance. So on the kilometer scale, there are 10 gray-white bars between 0 and 1, so each one is 1/10 of a kilometer. Similarly, on the feet scale, the bar is divided into 5 parts with the numbers 0 to 1,000, so each bar represents 200 feet. With this in mind, let's take an actual measurement to see how it works. Let's assume we took a measurement on our map between points A and B, and it came out to be 1.5 inches, and we want to know how many kilometers it is. Begin by placing the 0 on the compass scale in alignment with the 0 on the kilometer scale. Now look at the 1.5 inch mark, and you notice it is more than 1 kilometer, but you don't know how much more. To do this, we're going to slide the compass scale to the left until the 1.5 inch mark is aligned at the nearest whole number kilometer, in this case the number 1. So after sliding it to the left, you now look at where the 0 inch mark is on the compass and the corresponding point on the kilometer scale. As you can see, there are 2 gray-white bars in between the 0 on the compass scale and the 0 on the kilometer scale, indicating 2/10 of a kilometer. Since you know the total distance is greater than 1 kilometer from your original reading, add this to it and come up with a total of distance of 1.2 kilometers. To use the other scales, apply the same technique. Okay, let's get some practice doing this. Stop the presentation and pull out exercise 4. When you have completed the exercise, press the continuation button. Your answers should be close to the ones presented. Accuracy will vary depending upon where you actually take the reading and the accuracy of the ruler you're using. Plus minus 100 feet is good. Okay, stop the presentation, compare your answers, and when you're ready to continue, press the continuation button. The last of the 5 Ds in map reading is the designation of places on the map. Names of the roads, mountains, rivers, valleys, etc. will be indicated on the map. Be aware that not everything is labeled. Case in point, on this map, John Bull Flat, Van Duzen Canyon, and other points are labeled, as well as Wilbur's Grave. However, that hilltop off on the right-hand side of the map, slightly below center, is not. In addition to the 5 Ds, you will find the latitude and longitude of the location at each of the 4 corners of the map. Also along the top, bottom, and both sides, there will be 2 marks indicating the 2.5-minute marks of the map. They will only display the minutes and seconds of the coordinate and not the degrees, since it is understood that this number would not change from the one given on the right for the longitude or bottom for the latitude, as these are the starting points for the respective positions. These 2.5-minute marks divides the map into thirds, so if you connected these lines, it would look like a tic-tac-toe board on a 7.5-minute quadrangle map. Also, if you printed this map on a regular sheet of paper, it would print out 9 pages, which would have to be taped together to make the map. Or you can save it to a thumb drive and take it to a printer who charges about $1 for black and white or a couple of bucks for color. If you're going to use UTM or MGRS mapping system, easting and northing lines are noted along all the four sides. The easting and northing lines are connected on the map. However, on a color map, they are easy to see, but on a black and white copy, it's more difficult as they are faint. Lastly, there may be times when you're plotting a route, need to locate something, or triangulate a position, and in doing this, you discover what you are looking for is off your map. On the bottom of the map, you'll find a small grid with 8 squares surrounding a blank inner square. These are the map quadrangles that surround the map you are using. The names of the adjoining maps are listed right next to it for ease of looking them up. Okay, so just how can you get maps? You can purchase them at places like REI, or you can download them for free at CalTopo, which is one website so that you pick up an area of a map you want to view, as well as print the single sheet of paper. So it's customized for your needs. Its features include giving both degrees and UTM coordinates, ability to measure distances on the computer image, mark bearings, you determine the size of your map and the area, and then generate a PDF file for printing. When on the website, click the Print on top menu, then print PDF or JPEG, and the cost is free. A second website is the USGS. This site has the 7.5 map quadrangle, as well as other size maps. You can purchase them, but you can also download them for free, put them on a thumb drive, and take it to a printer for printing. The map size choices will cover from a 7.5 minute to a 1x2 degree map. When on the web page, go to Download Maps. Then zoom in or type in a location you want to print a map of. On the right-hand side of the page, there is a box called Mark Points. Click this. Now place your cursor anywhere on the map you want and right-click. A menu will appear. It may take time, but be patient. Look at the dates of the map choices as to size. Identify the one you want and click on the megabyte size of the map under the Download section. You'll get a message if you want to open it or save it. The choice is yours. Maps can also be obtained from your GPS or from Delorme Topo USA. The latter is a nice program that allows you to view the terrain on your computer in 3D as well as other features. This concludes the map module.